Director for Supply Chain Management at ARC Advisory Group. Joining me today is my colleague, Director of Consulting, Rick Briss. Rick, thanks for being here.
Thanks, it's a pleasure.
Let's talk about supply chain for electric power. You've written about energy transition, and as a late commissioner, you're directly involved with the electric grid transition to green power. What are the overall supply chain issues to make power greener?
Well, first, let's talk general about supply chain, whether it's green or not. And electric grids always have to have backup power. If a nuclear plant goes down or a gas plant goes down, there needs to be somebody to step in right away. So there's always an excess amount of generation on the grid. But back more to the green part of your question, what we have seen in the electric grid over the past decade or two is that we've seen coal decline as a gas species, in part because it's too expensive, and we've seen natural gas come in and take away the coal. But now what we are seeing is that of all the new electric power being added to the US grid, the vast majority is going to be solar, followed by wind, followed by gas. And therefore, what we're seeing is wind and solar are displacing natural gas as grid generating assets.
What are the driving forces for this transition to renewable, and how quickly is that going?
All right, well, that's a very good question. There's a number of driving forces. In some cases, utilities have specific regulations about the portfolio that they must produce. They must buy sources of electric power that are non-carbon emitting. There are also various forms of carbon taxes that are trying to discourage those types of generating assets that are, let's say, very high in CO2 emissions. And then finally, there are just general cost functions that some electric sources of power are more expensive than others.
There's a lot of interest in nuclear power, and some in the climate community support less. What is the role of nuclear power in the future?
Well, today, nuclear power and hydro are both non-carbon emitting. They're in the range of 20% of the grid assets. They're going to continue on as kind of a steady base load asset on the electric grid. There are more than 50 different new nuclear power plant companies trying to bring a new nuclear technology onto the electric grid. There's small modular reactors, there's advanced reactors, there's quite a wide range of interested companies, some of which are established and traditional, and some of which are new companies trying to bring a new nuclear electric power onto the grid. And the primary issues that they have are ones of cost. We've seen the Vogtle power plant come on grid, and however, its initial cost of $14 billion jumped to $30 billion. That's not a good omen. And we have companies like NuScale, TerraPower, Hitachi, and other companies bringing new assets on there. Their challenge is to get two things: one, cost and safety. And many of these new reactors are walk-away safe. They have no need to have electric power to keep those reactors cool during the shutdown.
How can the grid work and stay reliable with wind and solar when the wind does not blow and the sun is not?
Well, you would think that that's an impossible task, all right? But yet that's the exact task that the ISO New England and the other RTOs are faced with. You are going to see increasing amounts of wind and solar on your grid. You still must provide reliable power. So, wow, you see, well, how could that be done? And keep in mind that we still have some base load power, nuclear and hydro, on the grid. So we still have some base load that's not night to day, not intermittent, and but it's also not generally dispatchable. Generally, they are just solid base load on there. So what we're seeing is kind of a combination of new activities. We see massive amounts of lithium batteries being added to the grid at scale. So those lithium batteries can store power, put it on a bit later, and move power. There's also a lot of other energy storage technologies with either different kinds of batteries. There's gravimetric, there is thermal batteries, there is a lot of other assets that can be powered. There's also, of course, carbon capture and storage. So you could build a natural gas powered plant that captures the CO2 and therefore is able to provide those peak load shaving activities. And then there's one other very important thing that a lot of people overlook, and that is that, and that's kind of referred to as demand response. It was kind of one of the original concepts of the smart grid, but that is to say that that you might have an electric meter at your house where the price changes constantly throughout the day, and if the price goes up by a factor of 10 during the peak load event of 5 to 6 o'clock tonight, you might decide, well, maybe I don't want to consume power there. And in fact, if you even had advance notice, you might have pre-warmed or pre-cooled your house. You might have decided to defer your electric vehicle charging. If you have an electric hot water heater, you might have moved and shifted when that's going to heat hot water. So the demand response can also be hugely important. And you don't necessarily have to have a battery or a diesel generator, or you can't have a diesel generator, but a generator that could push power onto the grid to meet those peak loads. Just simply shifting power is going to be a very powerful force in the future.
Rick, thanks for joining me and sharing your insights on the supply chain for electric power.
Okay, keep the lights on.
My guest today was Rick Riss. Thank you for watching.